Anybody who's absent can watch this video and see what's going on. So yes, you're gonna get your piece of paper ready with the folding in half. Left side, you're gonna write down reactants. Yeah, get a pencil, pen ready. Reactants, products on the right. And then the back side, reaction number 2. We're gonna do a second reaction. I'm just kind of skipping ahead on some steps here. Reaction number 2, same thing, reactants on the left. So those that have their gloves on and goggles on and stuff, you don't need it quite yet. I just want you to get your notes ready if you haven't done that yet. So go ahead and take a break from the gloves, take a break from the goggles. Let's just get our piece of paper ready at this time. And this is the back side of the piece of paper. This is the back side. We're going to do 2 reactions. So we're getting our piece of paper ready. And it's folded in half. And the products on the right. Okay, awesome. So your back side of your piece of paper is reaction number 2, reactants on the left, products on the right. And then front side of your piece of paper is reaction number 1, reactants on the left, products on the right. So some of the notes that we're going to take, and we're going to start off with our first reaction, and the ingredients we put into our reaction are called reactants. I mean, it's just, repeated language meaning the same thing. These are the ingredients in our reaction, and we're actually we're gonna do something with this rock here. You guys also have samples at your table, so go ahead and take a look at this rock. Actually pick it up and feel its weight. I know it seems silly, but this is like what geologists do. So go ahead and pick up the rock at your table and look at it. What type of things are you guys seeing? I'll write it down on my piece of paper as well, so you know what type of notes to take. But what kind of things are you seeing with your little hand sample here?
Blue.
Some blue, okay. So like a blue. Are there any other colors that you see?
Green.
Yeah, definitely some greens, that's for sure. And it looks like a rock, so I'll just kind of put like rock. You can put like hand sample, that's fine too. And is this a solid, liquid, or gas?
Solid.
Yeah, it's a solid. So we're going to put a little S underneath it just to kind of indicate that it's a solid. All right. This type of rock, and here's some background information I'm going to give you. You probably read about it a little bit with some of your readings and exploring of the periodic table. This rock contains copper, and it's a type of rock called carbonate. It's a copper carbonate. So we're going to put that name here. It's called a copper carbonate. So copper carbonate. And chemically, it has copper in it, and that symbol is, as you guys know, Cu, and then carbonate is CO3. All of this information is for like the same hand sample, just this rock right here.
What's that bottom word under copper?
Oh, it's a carbonate, like carbon and then 8. Great question. That's the name of the rock. This is the chemical composition of the rock. This is the type of material. It's a solid. You drop it, it makes a thud, all that fun stuff. And we're describing some of the observations we have. It's bluish greenish rock. Now, some of the things that we're going to be doing with this rock is we're going to add and try and actually break down and dissolve this rock using a very specific liquid. What's the name of that liquid that you see up there?
Sulfuric acid.
Yeah, sulfuric acid. Yeah, these are all new terms, whatever. It's okay. I mean, this is the first time you guys are seeing it, and that's fine. Sulfuric acid, it happens to be 1 molarity. We're not here for the chemistry in detail like that, but that's the name of it. So we're going to put it, and we're going to add sulfuric acid. Or at least we're going to add copper carbonate to sulfuric acid. See if we can actually break down this rock a little bit so that we can try and extract the copper. That's the whole point behind this experiment is I'm telling you there's copper in this rock, but I want to prove it to you by the end of this whole experiment that there is copper in this rock. Yeah, but I want to prove it too. And you guys want to be able to prove it too, that sort of thing. You're like, Mom and Dad, what did I learn today? How to extract copper from rock. And now you know the steps. And is this a solid, liquid, or gas? This stuff in this bottle. Yeah, it's kind of swishing around. It's taking the shape of the container. Molecules are probably flowing past each other, that sort of thing. So definitely a liquid. We use a fancy little L for that liquid. And how would you describe the color of it? I know I have a blue piece of paper behind here, but how would you describe the color of that liquid? Yeah, clear. So let's write clear in the description. Okay. And the chemical composition of this one, I'm just going to give it to you. What makes it an acid is this H2 in front of it. And then an SO4 is the sulfuric part. It has sulfur and oxygen attached to it. What makes it an acid is the fact that it has the hydrogen in front of it like that. You'll learn in chemistry class why it's an acid. So we're going to crush up our rock beforehand. And so I'm going to also show you the crushed up version as well. You guys have a hand sample at your tables. How would you guys like describe the crushed up version? Does it look similar to the hand sample?
It looks gray.
Kind of a little bit of a grayer version. I mean, and when things get a little dusty, it gets a little gray. So that's a fair kind of color change, I guess you could say. But it's definitely the same rock. It still has those kind of bluish, greenish hues, things like that. So we're going to actually use the crushed up rock. Why do you think we're using the crushed up version as opposed to the hand sample in our experiments? Why do you think we're going to do this crushed up version versus the hand sample?
Easier.
Easier, okay. Why would it be easier though?
To dissolve together?
Say that again?
To dissolve together?
Something about it dissolving. Maybe makes it easier to dissolve. I like that little connection there.
Probably because we get like the inside of the rock, like more deep inside.
Yeah, you kind of break a piece of rock up and you're like exposing the inside. Ooh, that's a good way to put it. Yeah, you increase the surface area. There you go. Yeah, you're like as soon as you crack a rock open, all of a sudden the insides are now exposed. That's part of the surface area all of a sudden. And then you do it in half and half and half and half and all over again, and you break it up into little crumbles. Man, you're maximizing the surface area. So you're maximizing the potential for that acid to break this apart. So that's what we're going to do. That's why we're using the crushed up one. So let's go ahead and prepare ourselves to be able to use the acid and all that stuff. So we need to glove up and goggle up. The notes that I take on the piece of paper here are the notes I want you to have. But when it's time for the experiment, I want you to look at the experiment and think about your observations first. Do your notes second. So do your goggles, gloves, and I'm going to drop off the acid at your table. And then we're also going to put on our goggles too. If you don't want to put on our goggles, it's okay. You just have to sit maybe over here. So got your goggles on. It's not the most comfortable thing, but it's what you got to do for science. And then can we get that box of gloves back over here so I can get a pair as well? That'd be awesome. Ooh, safety first. Appreciate you. Thank you so much. Okay. And then also, can you hand this over to the other table? They're going to need that at some point. Awesome. It's just a spot to set aside your used filters and things like that. So we'll set it aside. All right. So let me kind of do that here. Okay. So I'm not trying to block you, but is that blocking your view of this at all? Okay, cool. All right. So when we do our substances and all that stuff, the things I'm writing down are the things I want you to have in your notes, but your priority is this experiment and safety and all that stuff. So I will document this. So if you need to catch up on notes, it will be available to you afterwards. So, no pressure there. So we have the acid at our tables. Oh, did I drop off 2 bottles over there or 1? 2. Give me one of those. I'm so sorry. Brain fart. There we go. Awesome. Thank you so much. Thank you. All right, cool. And let me get my gloves on as well. So when it comes to this first step here, we're actually going to just straight up add this sulfuric acid to this first cup here. We're going to do 10 milliliters. So whomever grabs the bottle, make sure you got your gloves and goggles on. And then you're going to take the cap off and just fill it up to the 10 milliliter mark. The 10 milliliter mark is on the side of the cup. So whoever has this step here, it's okay to pull the cup out and set it down and drop a little bit of acid in there. And it's okay if you just do a little bit and step back and take a look. But what do you guys see is going on into this so far? I just dropped a little bit in there. I see some bubbles, that's for sure. Okay, so I'll write that down in a moment. So far we see some bubbles. What else do you see, Brandon? You can also see it. You can see some color. What kind of colors do you see?
Brown.
Brown. Okay. Let me put a little bit in there, and I'm going to fill it up to the 10 milliliter mark. So it's quite up there. Here we go. There we go. Okay, cool. As soon as you're done filling it up, just don't forget to put the cap back on. Just don't forget the crushed rock. You're going to fill that one up to 10 milliliters. Mm-hmm. And over here, this group said that they saw bubbles and things like that. So I'm going to let Brandon actually kind of stir that around a little bit and help me with that chemical reaction. So go ahead and take this spoon here and do that while I document the observations we saw. So we saw some bubbles. Okay, bubbles. And then what kind of color do you see in the whole substance itself? What kind of color do you see in this whole liquid here? What kind of colors are you seeing? Kind of says brown. What was that again? Yeah. Stir it a little bit, just like Brandon's doing right here. Just a little bit of stir, not too aggressive, of course. You're stirring it up a little bit. It's kind of a brown, muddy. It looks like a liquid, right? But can you guys feel the crunching of the solids at the bottom, that sort of stuff? So it looks like it's kind of like a solid with a little bit of a liquid. I'm going to kind of put that there, a little bit of solid with a little bit of liquid. And in chemistry, we always indicate a reaction has happened by putting arrows. So we're just going to put arrows here to indicate that. Okay, so Brandon's been stirring here for about a minute or two. I want you guys to stir for about 30 seconds longer. Brandon's going to pause here. Awesome. Great job. Give you guys a chance to take your notes. Yeah, just giving a chance for everyone to catch their notes. And then also, is bubbles, is that a solid, liquid, or gas? Gas. Yeah, it's definitely some air in like trying to escape, and it kind of takes its own shape, that sort of stuff. So it's a gas. And so you guys should be good on stirring now. If you're already stirring, go ahead and take a pause from that. Go ahead and catch up on your notes now. But yeah, I agree. There was some bubbles that were happening, especially when you just put a little bit in, and all of a sudden you can kind of hear it fizzing a little bit. I know people described it as fizzing as well, so it's okay if you write that. But yeah, we had this kind of brown, muddy liquids with some solids in it and some gas that happened. Ooh. Anytime you have some sort of color change and you have bubbles that form or gas that's released, that's all of it is an indicator that a reaction has happened. Okay, cool. What I want to know is, like, the liquid here was clear beforehand. What I want to know is this liquid actually still clear? Is all the solids that's in the water, is that just little chunks of the solids over here? Or is that some other solid, going on there? I just want to see why it's so muddy. So that's where the filters are going to come into play, and the filter funnels are going to come into play. So we're going to separate these solids from these liquids as much as possible and really see what's going on here and see what's left over and see what that liquid is about. Is it actually still the sulfuric acid, or is it potentially something else? So this is where the filter funnel comes in place. You're going to put that filter funnel on top of those two other cups. And the course paper here, next time I'll have Brandon do it, but I'm going to show everyone, or maybe I'll have Karina do it next time. I think this will be fun. In chemistry, when you make a filter, they all look like this. It's just kind of round and flat, and you're like, how the heck do I make this a cone? So in chemistry, you're going to do like this. This is the coarse one, so it's kind of a rougher feeling looking one. You're going to fold it in half, like fold it in half like that. So it's just one fold. And then you're going to fold it one more time. So it's kind of like a little pizza slice, a quarter pizza slice. And then the trick is that when you tilt it on its side, you have to pick one layer apart. There you go. Just one. I'm trying to separate. There we go. Just one. All the other three layers are over there. So just one layer. and open it up into a cone. I'll let you guys work on that one. But the images are also on the instructions as well. So just double check the images as well. So as soon as you get your cone done there, you're going to put that in. And this is where I might need your help with pouring this in a second, but I want them to catch up on the cone. But we are going to pour this liquid into this cone so we can try and separate all the solids. We're going to filter out the solids as much as possible. I just kind of want to see if this liquid is still clear or if it's a different color, that sort of stuff. And, you know, color change indicates a reaction as well. So just covering our bases. Awesome. So whoever's holding the filter, make sure to have the glove back on. So it's okay if Brandon's doing that. Just don't forget to put your glove back on. And then I think it's a good idea to have somebody else pour and somebody else hold the filter, just to kind of help out a little bit. Awesome. So I'm just holding it down. That's all, because it's a little lightweight. It'll pop out. So whoever holds it down, make sure to have the glove on. Awesome. Perfect. All right, cool. Brandon, you're going to help me out here. You're going to take the spoon out and set it to the side on the paper right next to it. Awesome. Because we already stirred it up. We did the best we could. So go ahead and take this cup here, and you're going to pour it into this filter carefully.
Everything?
Mm-hmm. Yeah, everything. There you go. I know it's going to soak up. It's going to take a second. Yeah, there you go. And go ahead and set the cup back down just for a moment, just so we can look at the solids that are left over while the filter does its thing. But like, there's some chunks still kind of left at the bottom here, this leftover crushed rock, things like that. So there's definitely still some solids that we got out of here, but like, if we take this filter off to the side, we're gonna spread this out and catch the rest of our solids in here. But look at the color of that liquid. What color would you say the liquid is after we filter out all the rocks? Kind of a greenish, yeah, almost like a bluish greenish. I like that kind of combo color. I definitely see it off here to the side on the colorful piece of paper. So we're just going to scrape out the rest of the rocks into the filter just so we catch as much of the solid material as possible. If we can recycle this and use it later on and really extract all the copper out of it, that's pretty cool. So we're going to use as much of this material later as much as possible. So we're going to, maybe we can recycle that later. Maybe it's waste. I don't know. What's your opinion? Awesome. So Brandon, go ahead and take that filter out and be careful with the contents. You're going to put them on top of this gray cardstock so we can set it aside and dry and do all that stuff. So go ahead and take that filter out and set it aside. And I'm going to go ahead and fill in the rest of this paper. Yeah, and actually open it up so it's flat again. Like unfold the origami sort of thing. Perfect. Great job there. Great job there. So we're going to show off that. We're going to show off that spread out so they can see how it's done. So when you're done filtering out the rocks and you let it all drip down in this cup, you're going to take that filter out and you're going to fan it out on that gray cardstock. Let me know when you guys are through with that step. You can kind of see there's some other stuff kind of in the filter. What would you describe the other kind of stuff stuck in the filter around the leftover crushed up malachite?
The color?
Kind of an orangish color, like a dirty color. It kind of has a copper-esque look to it. I'm kind of curious to see if that's actually some copper, or maybe we got some early copper popping out. I'm not really sure myself, honestly. But yeah, it's something to note down. So we'll take those notes in just a second here. How far are you? Hey, keep your goggles on. I know it gets foggy too, because like my glasses get a little foggy and all that stuff. So we're going to take some notes for a second here. So it's okay if you pop off your gloves, especially if you're not handling the filter or anything like that. We're going to add a few notes here. Let me put this off to the side just for a moment while we do our notes. There we go. So we did get some of the solids out of here, but like that greenish sort of color, like, let me put it here a little bit more in the camera. There we go. It still looks like there's like something in it, right? There's something making it this kind of greenish, bluish color. It's the same color as the rock itself, right? So maybe there is a little bit of solid floating around in there, and it's just so freaking small that we can't see it. And usually when we have a situation like that where we have this solid that's like essentially dissolved, kind of using those words I used earlier, when it's dissolved in a liquid, we don't really indicate it by like a solid plus a liquid. We call it aqueous. So we're actually going to cross that out and call that aqueous with an A and a Q. When we have dissolved solids in a liquid, that's when we have an aqueous solution. So it's actually like a fourth type of like matter, which is kind of crazy.
Why is it called aqueous though?
I'm not really sure on that particular one. Like etymology, which is like the study of words and things like that. That's such a niche historical thing, and it's something like worth endeavoring for homework. And I definitely want to look that one up too. It's making me curious this week as well. But it's one of those exit ticket questions today, so I just want to make sure I say that out loud. And now you're gonna make me do some homework tonight. How dare you? No, but seriously, like this dissolved solid in liquid, we call it aqueous. That's the language in chemistry. And that dissolved solid here with this gas, so let's put some names to it. Whenever we have an aqueous solution and it's dissolved solids, it has to be with water in some way. It has to be dissolved solids in water. So that means that at some point we have H2O. Like, that's for sure. So it looks like we stole an oxygen and a hydrogen somewhere from over here. And so we got to do something with the copper, the carbon, and some of the other oxygens as well. So what should be left over is this copper, and copper is going to switch over here to the sulfate compound. So it's going to be copper sulfate. So that's actually copper sulfate bits floating around in water. But that gas is actually carbon dioxide. Does anybody remember the chemical formula for carbon dioxide? CO2. That's what I thought. But the chemical formula of copper sulfate is this sulfate ion, or I think it's compound or ion, I can't remember off the top of my head now, attached to this copper. So it's copper SO4. Now, if the stoichiometry is off or you're thinking about stoichiometry, we're not going to go into detail about this in this class. I'm just showing you the basic ingredients and how they're switching around. So that brownish, muddy stuff, I mean, honestly, it's like a blue liquid. So I'm going to kind of focus on that because we took the brown out of there. So it's like a blue, muddy sort of aqueous solution. And that aqueous solution is the copper sulfate with the water. And here's what it looks like chemically floating around in the water. And then, of course, those little bubbles were little bubbles of CO2 popping up. So it's very chemistry light. I'm trying to keep chemistry light here, but it is significant, some of the chemistry things that we are dealing with. So for the second reaction, I actually want to I still want to go one step further because this still doesn't look like copper, does it? Like, no. It's still blue. It's still kind of turquoisey, kind of murky liquid. Like copper is a solid. And how would you describe like the color of a copper?
Like brown.
Brownish. I've heard someone call it like a burnt sunset orange. I thought that was a very specific color there. So it's not there yet. We need to still do something with this copper sulfate. We still need to do something with it. So that's what's actually going to be an ingredient in our second reaction. So I'm going to steal this information over here, this blue, muddy, aqueous, copper sulfate. I'm going to steal this information here, and I'm going to put it as an ingredient or a reactant in my second reaction. So what was the description again? It was blue, muddy, and it was aqueous, and copper sulfate. And of course, the chemical composition for that is capital C, lowercase u, capital SO4. Okay. Now, like we did with our first reaction, we're going to add something to this blue, muddy, aqueous solution we call copper sulfate with a composition like you see here. So we're going to add something to it, and we're going to take notes on what we see pops out after we add something to it. The thing we're going to add is this. It is a particular element you read about. What element do you see there? What does that say?
Iron powder.
Iron powder. So we're going to add some iron to it. Why do you think we're adding iron to the whole mixture? What is it about what you read last class session that makes you think like, oh, iron should be better than copper?
Reactive.
There's something about it reactivity wise. Is it more reactive or less reactive than copper? It's much more reactive. So I want to trick this sulfur compound into bonding with the iron instead of the copper. That way it dumps out all of the copper. I want it to rain copper pretty much in my cup. I know it sounds weird, but that's what we want. So in the end, we should see, and here's the goal. We want to get this guy by itself. That is the goal.
We don't have the iron yet.
I have it over here.
Oh.
Yeah, you're good. I'm keeping it away from you. No, I'm just kidding. We'll bring it over there in a second. Okay.
What is the red thing?
Say that again?
The red.
The red? Oh, goal. That's our goal, is we want iron by itself. And of course, we want to see it in a solid form. It's called copper, so let's kind of fill in that information. And what does it look like again? Like a brown, kind of an orange color, right? So that's the stuff we want to see. So hopefully we see that towards the end. Okay. Cool. So let's go over here. I'm going to give you guys your powder first. And before you actually add the powder to it, the next step is to take 20 drops of your solution here and put it into the next cup. Let me get you guys a cup over here. Can you hand me one of those cups right there? Appreciate it. There you go. So you're gonna add 20 drops of that into that cup. And then here you go for your scoop. So somebody else is gonna get the scoop ready while somebody else holds the dropper. When you're done with that iron, pass it back over here so I can get some. Awesome. Oh, and since we're adding iron, let's go ahead and add that information to our notes. I'm so sorry. Oh my goodness, iron. Is that powder a solid, liquid, or gas?
Powder? Wait, is it solid or gas? Solid?
It's just a little tiny solid, isn't it? It's just really freaking tiny solid. So it's definitely a solid.
This is our spoon, right?
Yes. Yeah. And actually just do one big scoop or one good scoop. Yeah. Level it off at one solid scoop. But yeah. And then what color would you guys say that iron powder is?
Silver.
Silver. Well, you'll take a look at it in a second, but it is definitely like a dark gray, something like that. Oh, I'm going to write powder too, because it is definitely a powder. That does make a difference. Dark gray powder. All right, you guys got your little scoopy scoop, and then I forgot the next step. We're gonna do the 20 drops. So let me put my notes aside. We'll catch the notes in a second. But let's go ahead and get our parts together here. I gotta get my gloves on too. Okay. So as soon as I get the powder over here, yeah, powder. We don't have too much time. Awesome. Let's do one good scoop here. And so you're gonna go ahead and get the spoon and the powder. Say that again? Yeah. So I'm going to give you the spoon. Not too much there. There we go. There we go. There's your little scooper there. Okay. So we have the iron. Did you guys add it yet or no? Oh, you did. Okay. And then go ahead and add it in there. Oh, sorry. Oh, wrong one. Oh, well. So sorry. I messed up. No, it's okay. Watch this. Okay. Let's get another scoop. Go ahead and open this up. I did mess up here on this one. There we go. Go ahead and take another scoop. And then you're going to go ahead and add it in there. This is about 20 drops. Go for it. And then go ahead and stir. Stir. Okay. So now that we have our drops in there, you're stirring that third cup with the 20 drops of copper sulfate. You're going to put the powder with the copper sulfate, and then you stir it up. So just a little bit of stir, and it should change right away. So go ahead and pause there for a minute, Brandon. I think we have our reaction happened. So let me pull the spoon out just so we can see it a little bit clearer. But go ahead and take a look at that. Hold that cup gently and take a look at that, and go ahead and pass that to Karina and see what you guys see. What kind of colors are you guys seeing in there? What kind of colors? Kind of an orangey-ish color. Yeah, a little bit of that orangey brown. Do you guys see the transition happen? It's definitely different than that original. Here's the original iron powder. It's that gray brown, not even a brown. It's just kind of a gray, dark, almost like dark silvery-ish tone, especially if you put it under a microscope. What kind of colors do you see, Brianna? Kind of like a brown. Let me see real quick too. Awesome. So there it is. There's that little, and it looks like a solid in the bottom of this liquid here, right? So let's see if we could separate these solids and really get it by itself and really check out the color and the tones. And I'm kind of curious to see if that liquid is also still blue, you know? Do you guys see the color difference? Yeah, it's a big color difference, isn't it? So let's go ahead and get ourselves the fine filter paper ready. And so this fine filter paper, does anybody want to fold it up and try it out? Or do you think you got it, Brandon, or you want me to fold it? You think you can fold it? Okay, cool. So go ahead and fold it. Huh? Yeah, just the same way, yeah. And so what we're going to do is we're actually going to separate these solids. And I'll write you guys a note. I'll write you guys a note if need be. But we got a few minutes left. But let's go ahead and separate our solids, put it on our cardstock, and then you guys can literally run away. I think that would be good timing. So go ahead and fold it up into the filter shape. Get one of those little slivers off to the side. Awesome. So you're going to put the filter funnel back on the two remaining cups, the ones that we used originally in the second one. And oops, so sorry. You're going to put the filter in the first slot there. And then you take this little bit here, a little bit of solids and the liquids, and you're actually going to pour it out into that filter. And we're going to catch all of what I believe is the copper. And I just want to show you what it looks like without the liquid. Ooh. I'm going to try and get all of that. Look at all that precious little copper looking color. Oh, where's my stick? Do you have one of the stirring sticks? Oh, is it hiding? Oh no, it's right here. It's so sorry. It's right in front of me. Ah. Yeah. So let's spread it out and actually take a look at it. Let's get it out of the cup here. Okay, cool. So I think I got as much of it. I'm trying to get as much of it. I don't want to lose any product, you know. So let's go ahead and take it out and look at it. There you go. Does it kind of looks like a penny? A little bit? That little kind of luster to it? Kind of like, yeah, it kind of looks like a powdery form, I guess you could say. Yeah, you see it? Awesome. So before you guys take off your gloves and do all that stuff and run away, write your names on this cardstock and I'll clean everything up for you, okay? Yes, go ahead and write your names on the cardstock here and I'll clean everything up for you. They'll be here when you get back and then we get to look at the dry copper and take a look at it. Awesome. And so the rest of your notes are going to be, we'll have you guys turn in your worksheet after Thanksgiving. That's no problem. We'll figure it out. Let me fill in the rest of the notes for you. It is clear now, so that little liquid left over is clear. It didn't even drain out, did it? Like all the stuff that's on the paper here is all clear. So it's clear. Liquid. And the stuff that it is, remember the copper was dumped by the sulfate, so now the iron's attached to it. So it's going to be, what's the name of this if there's an iron in front of the sulfate? We call this one copper sulfate. What are we going to call the combination of these two? Iron sulfate. Yeah, baby. And that's FeSO4 and that's iron sulfate. So write that down. Turn in your worksheet if you feel comfortable with that. If you want to finish it over Thanksgiving break and do that later, that's fine. I won't put it in the grade book until later. Yeah, because that's all the notes that you needed to add to your worksheet. So you guys should have done the other stuff too. But if you want to do that other questions, turn that in with your worksheet if you're done with everything. If you're not done with everything, it's okay. I'm not going to flag it missing until we come back. I just realized we ran out of time. Yeah, put that in with your worksheet. Put your name on it at least so I know which one's in period 3. Hold on.